Hi everyone, how are you? My name is Nikunj Vyas and I study in 10th grade. So our today's topic is Bohr's model of an hydrogen atom. This is one of the very important chapter in class 12 physics, and especially for students who are preparing for IIT JEE and NEET. This chapter is one of the my favorite chapter because this chapter was and the theory because the theory was given by the one of the greatest quantum physicists of all time, Niels Bohr. He was a great scientist of 20th century. If you are interested in quantum mechanics, then I am pretty sure that you should know about Bohr's model and Niels Bohr's too. So in this video, I will not cover the whole model that was given by Niels Bohr because it was very vast model. But I will only consider some minor points which was given by Bohr, such as the three postulates and the radius of nth orbit and the velocity of nth orbit. In this video, I will not do the questions related to the IIT, JEE or NEET, but I will tell you the theory. Okay, so let's start. So Bohr's model. There were a lot of scientists who give the models of an atomic structure. For example, J.J. Thomson. And there are many other scientists, but one of the greatest scientists, Niels Bohr, gave the most accurate model which can explain the Bohr's model, which can explain the n atom. And this model was mainly for hydrogen atom because this was single ion atom. This model was for only single ion atoms. That's why sometimes people call it Bohr's model of an hydrogen atom. So let's start the theory part. Okay, so there were a lot of atomic structures which was given by different scientists. But then Niels Bohr gave his three postulates, which were one of the best among them. And the three postulates that I will discuss today are: number one. So the first postulate that was given by Niels Bohr was that if there is an atom, let's consider is nucleus. Okay, these are the shells of electrons around which around the nucleus. Because as we all know, the nucleus is the center of atom and it's very much dense. And the electrons revolve around the nucleus in a circular orbit. In reality, it is not properly circular, but according to Bohr, it is circular. So let's consider it circular. So Niels Bohr says that, for example, this is an electron and this is nucleus. So we all know that charge on electron is E, which is equals to minus 1.6 into 10 to power into 10 raised to the power minus 19 coulombs, as we all know. And the charge on proton on proton, it is the magnitude of charge on electron. Okay, means the charge is equal but of opposite polarity, and it will be 1.6. Okay, positive 1.6 multiplied by 10 raised to the power minus 19 coulombs, but of opposite polarity as compared to electron. So this is an nucleus. Okay, and we know that Z is the atomic number. Z is the atomic number, which is a number of proton present in our nucleus. Number of protons. Okay, number of protons present in our nucleus. Okay, fine. So the charge in the nucleus. What will be the charge in the nucleus? If the charge of one proton is this 1.6 into 10 to power minus 19 coulombs, then what will be the total charge on nucleus? And that will be Z times E, and E is the charge on proton. Okay, so and electrons are revolving around. So let's consider the radius of electrons be r, small r. Okay, so what will be the okay, so let's consider the mass of electron be m, small m. Okay, so this will be the first postulate of Niels Bohr. So the Niels Bohr says that he took some basic concepts from previous theories and says that the mv square upon r is equals to k z e square upon r square. So what is this? So first question is, what is this? So this is the centrifugal force, and you can also consider this. So you can also consider this centripetal force. It depends on your reference point, your position, that you consider it centrifugal force or centripetal force. And this is the Coulomb's force. How? Because we all know the Coulomb's force is K Q1 Q2 upon R square. Okay, fine. So K, it is a constant 1 upon 4 pi epsilon naught. Okay. So what is Q1 here? Let's consider Q1 be K, Z into E, ZE. Okay. Let's consider Q2 be the charge of electron, which is E, and radius is R, which is obviously square. Then K, Z, and E times E is square. E square upon R square. So this is the Coulomb's force. So he says that the electrons are in stable position. They are simply revolving around the nucleus. So the force exerted by the nucleus, which is obviously of attraction force because it's of negative, it's of positive. This force is cancelled out by a centrifugal force or maybe centripetal force, which depends on only your point of reference, which is this. This is also called the Bohr's first postulate. Let's consider it equation number 1. Okay, fine. So this was the Bohr's first postulate for hydrogen atom, or you can also consider it for all atoms, because in question solving or related to the IIT, JEE, NEET or other exams, we also solve the atoms of other elements. For example, lithium, helium, and other so on. Okay, so that's fine. This was the Bohr's first postulate. Okay, let's consider it equation number 1. Now, another postulate which was given by Niels Bohr was that he says that the angular momentum of electron, we all know that angular momentum is m v r. Let's consider its velocity v. Okay, so mvr is the angular momentum. He says that the angular momentum of an electron is the integral multiple of h upon 2 pi. Okay, wait a minute. But from where this thing come? N h upon 2 pi. This thing is, I wanna say that there was lot of interesting theories for this thing, N h upon 2 pi. Because even Bohr can't explain that how this come. Because this equation, the whole equation mvr is equals to nh upon 2 pi. This whole equation comes in the dream of Niels Bohr, and he says that this will be true. But further, after many years, de Broglie explained this equation. He says that let's consider an atom. This will be nucleus, and this is the shell, any shell considered, and there will be an electron revolving around this shell. So de Broglie says that every particle behaves like wave. We all know that de Broglie's equation, which is lambda is equals to h upon mv. M is the mass of that particle, v is the velocity of that particle, and h is the Planck's constant. And the value of Planck's constant is, okay, not the whole value, only the h, which is also called Planck's constant. Okay? And Planck is Max Planck, which was also a very great scientist of that time. H, its value is around 6.6 times 10 raised to the power, I think, minus 33 joules second, something like this. Okay, so according to de Broglie, he says that if the electron is revolving around the nucleus, then there should be also a wave, electrons wave, which is also a matter wave. Then there should be a matter wave, and that matter wave should not be destructive, means it should also be constructive. If the wave starts from here, then it also ends from here, not like this, not intersect the wave of, no, the wave should not intersect itself. And this point is very important, that the matter wave, according to de Broglie, should only be constructive but not be destructive. This should be constructive wave. So de Broglie says that, okay, if electron only, sorry, the de Broglie says that electron will only orbit the nucleus only if its matter wave will be constructive. If the matter wave becomes destructive, the path of electron becomes vaster and it can't revolve around it. So de Broglie says that, so the, let consider its velocity be v and radius be r. Okay. So de Broglie says that the 2 pi r, which is the radius, 2 pi r is a circumference of the whole circle, as we all know. This is the basic math. 2 pi r is equals to, he says that that this should be equals to h upon 2 pi, but integral multiple. If you I think if anyone has studied the wave chapter, for example wave optics, then he will be very happy with this equation. Why? Because he knows that this will be only the case for constructive interference, not for destructive. That's why he take n and not n minus 1 or maybe another thing, n. Okay, so this indicates that the matter wave should be constructive. If I take this 2 pi, 2 pi upon mv, sorry, there will be not 2 pi, there will be mv. That's de Broglie's equation, from de Broglie's equation. Okay, so he says that then if you take mv here and 2 pi here, then we get this equation. So what we are learning from this thing, the point to note here is that, let consider it lambda, which is lambda. So 2 pi r is equals to n lambda, which means wave can never be destructive. It will be always constructive, and constructive. No one will disturb him. Okay, fine. So this was a Bohr's second postulate, which was proven by de Broglie. So the first postulate of Bohr was explained by Bohr himself, but the second postulate was only explained by de Broglie. Okay, fine. So now I will tell you the third postulate, which was given by Niels Bohr. Okay, fine. So there was a concept at that time which is called the emission of an wavelength from an atom. We know that if we give energy to an atomic structure, an atom, overall all atom, then there will be then color spectrum in a spectra that we will get, and wavelength of different frequencies. But how that comes? The point is that if we have an atom, let's consider nucleus of that atom. This is the shell number 1. This is the shell number 2. This is the shell number 3. Okay, that's nice. That was very easy. Okay, so shell 1, shell 2, shell 3. First of all, I want to give names to the shells 1, 2, and 3. Let's consider that there is an electron here, electron of charge minus A, as we all know. If this electron jumps from here to here, shell number 3 to shell number 1, Niels Bohr says that there is a fixed emission of an energy. There will be a fixed emission of an energy in this whole process, and that energies and the energies of shells are also fixed. For example, this will be the shell number 1. So here the shell already have energy 1, energy 2, energy 3. So the energy which will release in this whole process will be the mode of energy emitted. by an electron is equals to mod of, which is equals to mod, which is magnitude of E3 minus E1. This was the postulate, third postulate given by Bohr, that energies of different shells are constant. Means if I take one atom from here, uh, okay, let's consider another example. If I have an electron here and I take this electron from first shell to second shell, okay, so what will be the energy given to this electron? Because in this process I have to give the energy to electron to come from its lower shell to higher shells. So so the energy which will be given to the electron, E given, means energy which will be given equals to the magnitude of E2 minus E1. This is the energy given to that electron for jumping from its shell number 1 to shell number 2. And yeah, suppose that I have an electron here. Let's suppose shell number 1. Yeah, shell number 1. And I have jumped this electron from shell number 1 to infinity. Okay, nice. Then what will be the energy given to this electron? What will be the energy given in this case? So the energy given in this case is E1. How? Because mode of energy of nth shell, which is infinity, minus E1. So energy of the energy of infinite orbit is 0, and I will discuss this further in this lecture. So this will be 0, so it will come as mod of E1. Okay, that's nice, that was nice. So I have given you 3 examples to explain this postulate, which is also a very important postulate. And further in this chapter there will be another formula called Rydberg's formula and series emissions, for example Lyman, Balmer, Paschen, and lot of other series, which will give you the idea that how the color emission will occur. Okay, so these are the 3 postulates which were given by Niels Bohr. I think I have explained well. So now we will see another thing, which is called the radius of nth orbit. Means if I have an radius, okay, if I have an atom nucleus, this is a nucleus of atom, shell number 1, shell number 2. Okay, shell number 1, shell number 1, shell number 2. Let's consider the radius of this shell be r. Let's consider this is a nth orbit, not second orbit. Let's consider it nth orbit. Okay, fine, no problem. So what will be the radius of nth orbit? This nth can be 1, 2, 3, and so on to infinity. So what will be the radius? So as we all know, the Bohr's 2 postulate which was given. The first one was mv square divided by r is equals to k z e square upon r square. This was, let's consider it equation number 1. And the second postulate which was given by Niels Bohr was the angular momentum of an electron is the integral multiple of h upon 2 pi and h upon 2 pi. Let it be equation number 2. Now I say you that put the value of v from here to here. So if we, I think I write here, if we put the value of v from equation number 2 to 1, then what will we get? So from equation number 2, V is equals to NH upon 2 pi mv. Let it be equation number 3. Now put equation number 3 in equation number 1. That's fine. Now what will happen? If I put this value, equation number 3, which is the value of V, in equation number 1, this one, then what will be I get? So this will be M. So M V square upon R. So V square N square H square divided by 4 pi square M square V square times R. Okay, fine. So then now, oh sorry, here's a R square. Okay, fine. Is equals to, I think I have to raise this equation from here. It is taking my space. So where I have equation number 3, so I have to write equation number 1 here. So what was the equation number 1? K Z E square upon R square is equals to mv square divided by R, equation number 1. And equation number 2, which is mvr is equals to nh upon divided by 2. Okay, equation number 2. So is equals to, from when we put equation number 3 in equation number 1, then we get this is equals to k z e square divided by r square. Okay, so I have to solve it. So r square will be cancelled out with r square, no problem. Okay, then if we take the radius one side and this, okay, now I am doing the cross multiplication of only r, then I get m n square h divided by 4 pi square m square k z e square is equals to r. If I see here that which of the following things are properly a constant, I will see 4 pi square m square k e square m h square. These are terms are properly a constant. So Bohr just simply take the values of these all constant and make another constant which is called r naught and n square divided by z. So this is radius of nth orbit. Okay, so the radius of nth orbit is r naught n square upon z. Sometimes people also write this a naught, and there is no any difference, but I always write r naught. So what will be the value of r naught? So the value of r naught is 0.529 angstroms. So if you don't know what is this terms angstrom, then that 1 angstrom is equals to 10 raised to the power minus 10 meters. This is the 1 angstrom. Okay, fine. This was the radius of nth orbit. So how to find the velocity? So the Bohr simply says that just put this equation number 4 in equation number 2 or 1 as you wish. If we put equation number 4 in equation number 1 or 2, then we get velocity of nth orbit. And what will be the velocity of nth orbit? So the velocity which will come, velocity of nth orbit is equals to v naught z upon n. Z is atomic number, N is the principal quantum number, means the nth orbit. This will be the, and for which orbit we want to see the velocity. And what will be the value of v naught? V naught will be equals to 2.2 into 10 raised to the power 6 meters per second, and the meters per second is the SI unit of velocity. Okay, so this is the very little concept which was given by Bohr, and I have just covered a little part of the whole Bohr's model, because it is only all about it is not only all about this thing, which is velocity of nth orbit, radius of nth orbit, these two or three postulates, but the whole model is all about the including this to the I want to say that to the energies of nth orbit also, and we will definitely do the derivations and see the energies of nth orbit and Rydberg's formula, X-rays, but in next lecture. Okay, so this was my today's lecture, in which I have discussed some little concepts related to the Bohr's model of an hydrogen atom. So I hope you like this video. Thank you for watching this video. Bye.